Hey, a few thoughts from section 1.3. Notice in R2 how there's this subspace A0, so that A is a real number. That's a subspace in R2. And there's also this subspace in R2, sort of 0b. And they both look like just sort of like a copy of the real numbers, but somehow these two, let's say pieces, they're kind of like pieces of R2 make up the whole. Isn't that funny? So like, if you have a component there, oh, maybe we should say 0b there. Somehow those two make up everything. So I want to talk to you about something that's a piece of mathematics that comes up quite a bit. So if you have two sets, S1 and S2, in V, a vector space, that are non-empty, then we say the sum, you can take any two sets in a vector space. You have to know what it means to add two elements, but then the sum of S1 and S2, which we denote sort of the standard way. Remember, these are sets, but we can denote it S1 plus S2, is just the set of x plus y such that x is in S1 and y is in S2. So, for example, up here we have like W1 plus W2 would equal the set of things, well, 1 from here, A0 plus 0b, such that A and B are real numbers. Well, if you think about it, that's kind of interesting because, frankly, you can get anything by adding two things like that. So this is not always true, right? These are sets. They might not even be subspaces in their own right, but these are subspaces. So we have one more definition. A vector space V is called a direct sum of W1 and W2 if, and you might have guessed from me actually labeling them W's in the definition, if W1 and W2 are subspaces of V. So, well, it makes, if we're going to call it a direct sum, they have to be subspaces. 2, if these two sets really don't overlap except for 0. And can you see that that property is actually true here? The only element these two have in common, there's no redundancy here, right? The only element they have in common is 0, 0. And 3, W1 plus W2 is equal to V. And that's what we showed up here. This is actually equal to V. And we write this direct sum W1 circle plus W1 direct sum W2. Hope that's helpful.